This is the summary created from the video. Lecture 27 Multithreading-I. This video introduces the concept of multithreaded programming, where multiple parts of a program can execute concurrently, and explores topics like parallel execution, synchronization, and resource sharing. It explains the difference between single-threaded and multithreaded execution, with multithreading allowing threads to run in parallel, exchange data, and utilize common resources for enhanced efficiency. The need for multithreaded execution arises from the desire to run multiple tasks concurrently, such as browsing, typing, and playing music simultaneously, which can be achieved through multitasking or multiprocessing. Multitasking involves sharing CPU time and resources among multiple programs, utilizing time slicing to allocate CPU cycles, while multiprocessing enables parallel execution across multiple processors. High-performance computing systems like Pentium Zen, Athlon X2, and Cray X1 facilitate multiprocessing environments, which are conducive to multithreaded program execution for improved speed. It distinguishes between processes, which are programs loaded into memory, and threads, which represent sequential execution of instructions within a process, with multiple threads enabling concurrent execution and data sharing. Real-world applications of multithreaded programming include Gmail servers processing user requests concurrently, proxy servers forwarding requests to distributed servers, and PCs allowing tasks like document editing and printing to run in parallel. In Java, multithreading is achieved through the java.lang package, which provides the thread class and runnable interface, with methods like start, run, join, and sleep controlling thread execution. An example demonstrates creating multiple threads with custom execution logic by extending the thread class, overriding the run method, and launching threads with unique behaviors like printing negative, even, or odd numbers. In summary, multithreaded programming enables optimized performance through parallel execution, as illustrated in common applications, leveraging techniques like multitasking, multiprocessing, and Java's thread class and runnable interface constructs. Please stay tuned for more summary videos.